Now, today we're going to be talking about something called empirical or statistical probability, which is based upon observations versus classical, where we're expecting everything to have an equal amount. Now, example 6, we're going to start with an example. It says a company is conducting a telephone survey of randomly selected individuals to get their overall impression of the past decade. So far, 1,504 people have been surveyed. The frequency distribution shows the results. What is the probability that the next person surveyed has a positive overall impression of the 2000s? Okay, so we're looking at positive. So that would be 406 divided by the total number of respondents, which is 1,004. Now you probably can see I can take out at least a 2. And so what we're going to do to make this easier to simplify is we can go to our graphing calculator and we can actually do, it was 406 divided by 1,054. And when I change that, it's really just taking a 2 out. And so I get 203. This is the easiest. Well, actually, you know what? We'll give it to us as a decimal. That's fine. A decimal to 4 digits is okay, which would be 0.2699. So 0.2699. Okay? Here's one that you can try on your own. It says an auto insurance company determines that every 100 claims, 4 are fraudulent. What's the probability the next claim of the process will be fraudulent? So think about how many there are divided by how many claims there can be. All right, example 7. It says you survey a random sample of 1,000 employees at a company and record the age of each. The results are shown in the frequency distribution at the left. If you randomly select another employee, what is the probability that that employee will be between 25 and 34 years old? So from 25 to 34, that is right here. And so that would be 366 divided by the total number, which is 1,000. And so we can easily, on a calculator, figure out that 366 divided by 1,000 is 0.366. All right, there we are. All right, now in the try it yourself problem, it says find the probability that an employee chosen at random will be between 15 and 24 years old. I'll erase this to make it easier to see. All right, so we've looked at these two types so far. So classical or theoretical probability, or empirical or statistical probability. So this one is when everything is likely, right? When everything is likely, equally likely, I should say, equally likely to happen. This is what we use, classical. Now, if we don't know that everything is equally likely and we use observations, then we're going to use empirical, where they give us our data. So I'll say data is given, right? That's important. Now, there is a third type of probability. It's called subjective probability. Subjective. Subjective probability is the result of intuition, educated guesses, or estimates. So, for example, it says, given a patient's health and history, a doctor may feel the patient has a 90% chance of full recovery. And so that's based upon intuition, educated guess, estimates, maybe based upon how they could take their medicine, how their body responds to that kind of stuff. Okay? All right, so let's look at that. All right, you'll notice I have to erase some stuff up here. Okay, example 8. Example 8 says this. It says, classify each statement as an example of classical, empirical, or subjective probability and explain your reasoning. Okay, so I'll write just down what they are, and then we can talk about it. So it says the probability that you will get the flu next year is 0.1, which would be like 10%, right? Now, what do you think that is? Well, first off, we think about this. Is everybody in the whole world have a 10% chance of getting the flu? Well, the answer is no, because some people have more of a chance of getting it, and some, like Eskimos who live in the Arctic, aren't around people, they're probably not going to get the flu. So this one is not classical. Then we look at empirical. Well, notice we don't have any data or anything like that with other people and what their percentages are, so that's not empirical. So this one is considered subjective, okay? And that could be just someone saying, hey, you got 10% chance of getting the flu. It's all subjective. You can't, there's nothing behind it. There's no teeth behind it right now, okay? Now, number two. Number two says the probability that a voter chosen at random will be younger than 35 years old is 0.3. Okay, well, that one, okay, notice it says it says younger than 35. So there is some sort of data that we're looking at, right? And we're comparing ages of other people. And so then this one would be an example of empirical or statistical. Okay, that's part B is empirical. Finally, the last one, okay, it says the probability of winning a 1,000 ticket raffle is 1 out of 1,000. Well, that's clearly classical because you have one ticket and the chances of winning are 1 out of 1,000. Okay, so we used all three. So what I would like you to do is I'd like you to try this one right here. It says based on previous counts, the probability of a salmon successfully passing through a dam in the Columbia River is 0.8. What type is that? Okay, so I'd like you to figure out which type that is now. Okay, now here's something that's interesting. Okay, probabilities are generally numbers that are either a fraction or decimal, but all probabilities have to be between 0 and 1. And so think about this. Unless your teacher gives you extra credit, you can only get from 0 to 100% on a test, right? And so that would make sense that your probability of something happening is 0 to 100. The same thing as, you think of the weather. You either have a 0 to 100% chance of rain, right? You can't ever, you'd never go and you'd probably want to fire the weatherman if he came up and he said, there's a 130% chance of rain today. That's ridiculous. Now, there are times when percentages are over 100, but that has to do with probabilities. That has to do with increasing and decreasing, which is not what we're talking about, okay? Now, here is a scale that's kind of good to look at. It says if a probability is nearly zero or is zero, it's considered impossible. And if something is 1 or 100%, we consider it certain. So if you think about it, let's say today there's a 70% chance of rain, it's probably likely that it's going to rain today. However, if we see 30%, okay, that means it's probably unlikely going to happen. And so our likely to unlikely is this span right here, okay, between over the 50%. And if something's 50-50, you have an even chance of it going either way. Okay? Now, the next thing we're going to talk about is something called a complement. What is a complement? Well, a complement is the opposite of something happening. And so, for example, this is interesting to look at right here, that the probability of E happening and the probability of its complement add up to 1, which means the probability of E is 1 minus its complement, or more importantly, right here, the complement is 1 minus the probability of something happening, okay? And so up here at the top, they give us an example of rolling a 5 or 6. And so the probability of rolling a 5 or 6 would be 2 out of 6 right there, or 1/3. And then the probability or the complement would be 2/3. And you'll notice, or it'd be 4 out of 6 and 2 out of 6, but you see what I'm saying. And so you'll notice that 1/3 plus 2/3 is going to equal 3/3, which we know to be 1. So we know this is true. All right. So let's look at example 9. It says, use the frequency distribution in example 7 to find the probability of choosing an employee who is not between 25 and 34 years old. So if we go back up to example 7, right? Example 7, it says the probability of 24 to 35 was that 3.66. So the chance of that not being it, there are two different ways you could do it. Well, one, you could add up all the other ones, or we know that the probability of not 25 to 30 is equal to 1 minus the probability of 25 to 30, right? 34. And so that would be 1 minus 0.366, which would end up being, I'll use my calculator for this one. 1 minus 0.366 is going to be 634. So there, that's the chance of it not being between 25 and 34. And you could have found it by adding up all the other probabilities as well. Okay, here's one you can try on your own. Now, using a tree diagram for example 10, it says a probability experiment consists of tossing a coin and spinning a spinner shown at the left. The spinner is equally likely to land on each number. Use a tree diagram to find the probability of each event. Okay, so the first one is heads or tails, and then spinning a spinner between 1 and 8. And so we know 2 times 8 would be 16 different things, which you see if we count all these, there are 16 of them, right? Okay, so event A says that tossing a tails and spinning an odd number. So for sure we go to tails, and now we need odd numbers. So that would be tails in 1, tails in 3, tails in 5, or tails in 7, which would be 4 out of 16, which would be 0.25. So that's for number 1, okay? 0.25. Now event B, it says, we're asked to find, event B is tossing a heads or spinning a number that is greater than 3. So tossing a heads is this one right here. So all of them. So that's the 8 right there. Or spinning a number that's greater than 3. So that could be 4, 5, 6, 7, 8. And you'll notice I already counted those 4, 5, 6, 7, 8 over here. So I don't have to recount them. So there's 8 here, and then 1, 2, 3, 4, 5 more over here. So 8 plus 5 over 16 is going to be 13 out of 16. Now I don't know what that is off the top of my head. So I go to my calculator and I do 13 divided by 16 is 0.8125. Okay, so there's the probability of tossing a heads or spinning a number greater than 3. Okay, here is a couple guided practice problems. You can use the same tree diagram right here to answer those questions now. All right, last problem we're going to look at. It says, your college identification number consists of 8 digits. Each digit can be 0 to 9. And each digit can be repeated. So we know that there are 10 choices from 0 to 9. Okay. And what is the probability of getting your college identification number when you randomly generate 8 digits? Okay. So the first digit, okay, can be 10. Second is 10. Third is 10. Fourth is going to be 10. Fifth is going to be 10. Sixth is going to be 10. Seventh is going to be 10. Eighth is going to be 10, which another way we could do is just 10 to the 8th power, right? And so I'll go to my calculator and I'll do that. I'll say 10 to the 8th power is 100 million. So the probability of that happening would be, you only have one college ID number, so it'd be 1 out of 100 million, which if you wanted that as a decimal, it'd be a lot of zeros with it. So we can just leave it like this if you'd like. Okay. And finally, the last one, I want you to try this one. It says your college identification number consists of 9 digits. The first 2 digits will be the last 2 digits of the year you are scheduled to graduate. The other digits can be randomly from 0 to 9, and each digit can be repeated. So now notice that there's only one choice for the first 2 digits, and then 10 choices for the last 7. So now you can go ahead and try that and find your probability of getting your college ID number. Okay? Good luck. Let me know if you have any questions.